Question 17, and this one looks nasty, but I'm ever so sure it's going to be fine. So, a solid cone is joined to a solid hemisphere to make the solid T shown below. We've got diameter of the base of the cone, and the hemisphere is 7, which means that it's got a radius of 3.5 because that's half the diameter. The total volume of T is 120 pi, so we're going to keep things in terms of pi, which is useful. So we've got to calculate the height of it. So okay, it's all going to be fine. I know, for example, actually here, that's 3.5. So we've got 3.5 here, and then y is going to be the height. So y will equal the height of the cone plus 3.5. Let's not mess around with that. That's supposed to be a 3. Okay, so the volume of a sphere, 4/3 times by pi times by that radius squared, which is 3.5. And then, radius cubed, because that is a 3. And then we're going to halve it. So that's all going to be divided by 2. Then we need to add the volume of the cone. So that is 1/3 times by pi times by 3.5 squared times by the height, which I'm going to call h. And all of that equals 120 pi. Isn't that lovely? Okay. Good job we've got the calculator. So 4/3 times by 3.5. I'm going to ignore pi for all of this. 3.5 cubed. And then divide it by 2. And then I'm going to hit the SD button, and it's gone to 343 over 12 pi. So I've just put all of those calculations in and used the SD button, which has turned it from a decimal into a fraction, which is lovely. And then that's going to be added to. So let's work this next bit out. 1/3 times by 3.5 squared. That's all I need to do. That is 49 over 12 h pi. And that equals 120 pi. Okay. Next step, divide everything through by pi. So 343 over 12 plus 49 over 12 h equals 120. 120 take away the 343 over 12 means that 49h over 12 equals 1097 over 12, which means that 49h equals 1097, and then 1097 divided by the 49 gives us, well, that's hilarious, I'm going to round it now, 22.387755. Remember, I'm adding on that 3.5 because that height I found is just the height of the cone. So I'm going to add that 3.5 and then I'm going to get 25.88775551 to 3 significant figures means it's going to go to 1 decimal place, so 25.9. Okay, the diameter of the base of the cone and the diameter of the hemisphere are both increased, right? So that means it's going to get wider. And the volume is going to stay the same, which means that the height is going to get smaller. So my answer will be y will be smaller. And that's question 17. Question 18. Triangles, angles, lengths. I think I smell trigonometry. So it says we've got to calculate the length of QS, which I'm going to call little r, and you'll see why soon. You must show all your work and give your answer correct. 3 significant figures. So our first element is, if we had little s here, we'd be able to work out r using the sine rule. Fortunately, we can work out s because of the cosine rule. So a squared equals b squared plus c squared take away 2bc cosine a. So s squared is equal to 11 squared plus 9.4 squared take away 2 times 11 times 9.4 cosine 27. Okay, so let's just work out bits of this. So 121 plus 9.4 squared gives us 209.36 And then 11 times 9.4 times 2, 206.8 cosine 27, times that by cosine 27, and then 209.36, 209.36, take away the answer, s squared is equal to 25.0998508, and then we square root s, which is roughly going to be 5. Okay, 5.009975129. Okay, so that's what s is. And I know to find r over sin 88, which is sin r, will be equal to s, which is 5.009975129 over sin 41. I don't want to round it because I'm using my previous answer. I don't want to get an inaccurate answer. So 5.009975129 sin 88 all over sin 41 will give us our answer. So answer, I've kept it in my calculator. Sin 88 equals, divided by, is that going to be right? Yeah, it is about right. Divided by sin 41, and that gives us an answer of 7.6318188124, 7.63. And that's the three significant figures. Question 19. So we've got function of g and a function of h. Our first question, find g of 16, which means we're going to put 16 into the function. That gives us the cube root of 32 take away 5 is 27, and that's 3. Okay, the next bit. So find h g minus 1 of x. So that means the inverse of g first, and then that's going to go into h. So the cube root of 2y take away 5 is equal to x, and then we're going to get it to y equals in order to have it in that inverse form. 2y equals x cubed, y equals, sorry, I forgot my plus 5 there, a half x cubed plus 5. Okay, that's done. Then that needs to go into h, which means that we've got 1 over a half x cubed plus 5, like so. Can we leave it in that format? If I'm honest with you, I don't know, it looks a little bit untidy. So what I'd probably do is, well, it's going to be effectively divided by, we're kind of dividing it by a half, and then this bit's multiplied. So what I can do is say keep, change, flip. If we're dividing by a half, we're multiplying it by 2. So we can bring that half up to the top, which then leaves us with 2 over x cubed plus 5. Bit of a headache, but practice these ones and they'll give you valuable points at the end of your exam. Question 20. So we've got circle theorems. So for our first one up here, BAD is equal to 132 divided by 2, 66, 66, because the angle at the circumference is half the angle at the middle or the center. Okay, we've got BCD is 180 take away 66, which is go away. Just gonna rub this out. So that equals 114 in there, because it's a cyclic quadrilateral. Okay, we're looking for CDE, so I can work out DCE, which is 66 angles on a straight line. Sum to 180. So that's 66. And then CDE is equal to 180, take away 60, take away 66, take away 16, which gives us 98, and that's angles in a triangle. In a triangle, sum to 180. Done.